Welcome all for the today's session. So today we continue with our biostatistics module, and today's talk is about correlation, scatter plots, and regression. Okay, again these are important concepts from MRCOG point of view, and very frequently tested in the examination. Okay, so we continue. We begin with our session for correlation, scatter plots, and regression. Okay, so why should we study the relationship between the variables? Okay, sometimes research questions what we ask, do two variables move together? Okay, maybe it may be related to the gestational age and the birth weight. It may be related to the height and weight. It may be related to the BMI and some other thing. Okay, exercise and the BMI. So there is a correlation. So we are talking about the two variables. So here comes the correlation, because we are talking about the relation between the behavior between the two variables. Okay, the example is gestational age and the birth weight, height and the weight, maternal age and the risk of the Down syndrome, education and income. Okay, so these variables have got some association with each other. Okay, so the purpose is to identify the relationship, to measure the strength of the relationship, and we should be able to measure the one variable from the another variable. Okay, if we know that they are related to each other, and if we know one variable, we should be able to calculate the value of other variable. Okay, and for this, scatter plot helps a lot. Okay, so how does this scatter plot helps? Okay, so the scatter plot is a graph which is used to display the relationship between two quantitative continuous variable. Okay, so our variable should be quantitative and it should be continuous variable. Okay, so scatter plot is a graph which is used to display the relationship between two quantitative continuous variable. Okay, so we have got a x-axis, we have got a y-axis. So what is taken on the x-axis is the independent variable. What is taken on the y-axis is the dependent variable. Okay, the one which varies with respect to independent variable, that is taken on the y-axis, and each dot will denote your one observation or one individual. Okay, look at this particular graph which talks about the gestational age and the birth weight. Okay, so gestational age is the independent variable and birth weight is the dependent variable, because birth weight will depend on the gestational age. Now here there are certain points which are marked with red. There are few points which are marked with the green. Okay, and there are certain which are marked as a triangle, and there are which are marked as a circle also. Okay, they are the male and the female, like that. Okay, just concentrate on the red and the green. Okay, so the one which are non-hypertensive, that is normotensive patients, are red, and hypertensive patients are green in color. Okay, now if you see this, the line for the growth between the birth weight and the gestational age, you will find that there is some relation, but the normotensive patient, that is the red patients, they are more closer to this red line, while these green patients, those hypertensive, they are little away, more of the greener are away from the line. Okay, so we are able to take out some conclusion from this particular thing. Same thing, you look at this particular plot. Okay, so these are the individual observation and this is the line. Okay, so most of the observations are close to this line. So what we can say, first thing, uh, there is a relationship. Okay, and there is a positive relationship now, or there is a perfect relationship, linear relationship here. Here what you see, there is a line. They all points are also growing, but they are away from this particular line. So that means it is a weak positive correlation, while it is a strong positive correlation. Okay, so that is what is the interpretation. So as gestational age increases, birth weight increases. So this suggests the positive relationship. In both cases, you get this positive, both hypertensive as well as normotensive also. Okay, but you are also able to see some strong relationship and weak relationship here also you are able to see. Okay, so as the gestational age increases, birth weight increases, this suggests that there is a positive relationship. Okay, why scatter plot is important? Before calculating the correlation, always look at the scatter plot, because it gives us a lot of information. It helps to identify one positive relationship, whether it is there or not, negative relationship that can be calculated, linear relationship that can be pointed out, non-linear relationship that can also be commented about the on the scatter plot. And if there are outliers, that also we can detect from the scatter plot. So scatter plot helps us to find out whether there is a linear relationship or non-linear relationship, whether there is a positive relationship or negative relationship, and are there any outliers. So that is what is the importance of the scatter plot. So what are the forms of relationship? So it may be one, linear relationship. Okay, that means variables follow approximately a straight line. Okay, in linear relationship, variables will follow approximately a straight line. Example are height and weight. Okay, gestational age and birth weight, education and income. They will follow approximately straight line. So this is the perfect positive correlation. Okay, this is the positive correlation. Okay, this is the negative correlation. Okay, so as one is increasing, the other is decreasing. Okay, so this is the negative correlation. This is the perfect negative correlation. This is the perfect positive correlation. Now look at this. Okay, this is also increasing. One is increasing, the other is increasing. Okay, but here is a low degree of positive correlation. Okay, now here one is increasing, other is decreasing. This is low degree of negative correlation. Okay, now here high degree of positive correlation. See here, here it is a high degree of positive correlation. Here it is a high degree of negative correlation. Here there is no correlation. Here also there is no correlation. So if you have got a scatter plot, you get a lot of information. Remember, practically we will never get a perfect correlation. Never it happens in the practice. Okay, you will always have such kind of graphs. Okay, or such kind of thing. It may be poor, it may be strong relationship. Okay, it may be positive, it may be negative, or sometimes there may not be any relation also. Okay, so from examination point of view, it can be summarized using this relationship can be summarized using Pearson's correlation coefficient. Okay, so please remember this concept, Pearson correlation coefficient, which is denoted as a R. Okay, so Pearson correlation coefficient will tell us about this relationship. This is denoted as R. Okay, this talks about the linear relationship. Okay, the other relationship is a non-linear relationship. Okay, it cannot be explained by the straight line. It may be U-shaped, J-shaped, or it may be curved. Okay, so example is a curved or a plateau relationship, like dose response relationship. Low dose has got little effect. Moderate dose will have major effect, and at high dose there will be plateau. Okay. Linear relationship is expected from the candidates. Non-linear relationship generally they don't ask. We will not go into the details. This is just for the understanding purpose. In non-linear relationship, you can have U-shaped, J-shaped, or the curved. Okay, so curved or plateau relationship. When you give certain drug, what happens? You need to give appropriate dose, then only there will be effect. So if you give drug, but at lower dose, there will be no effect at all. You got it? So you are giving the drug, but no effect because the dose is low. When you increase the dose, the effect will increase. Okay. And as you increase the dose, the effect will go on increase to some extent. After that, you increase the drug to any level, the effect will not increase, because whatever the receptors on which the drug is acting, if all the receptors are saturated, the drug will not give any further effect. Okay, the drug will give the effect only till the receptors are occupied. Okay, so this kind of relationship. So here you cannot say it is a linear relationship. Okay, so it is little different kind of relationship. It is a plateau or curved type of relationship. Okay, so here it is something like that. You give the dose, there is no relationship. You increase the dose, the effect will go on increasing, but at certain point it will become a plateau. Okay, so this kind of relationship also you can get. Sometimes you can have U-shaped relationship. Okay, U-shaped relationship. This you can get at extremes of BMI. Okay, suppose you have got low BMI and you talk about the adverse obstetric outcome. At low BMI, you will have adverse outcome. At very high BMI also, there will be adverse outcome. But if the BMI is normal in this particular range, there will be less morbidity. Okay, so here there is a U-shaped relationship. Okay, So maternal BMI and pregnancy complications, both very low BMI and very high BMI will increase the risk. Okay. So risk is highest at both extremes. So you will get a U type of relationship. Okay. So these are the non-linear type of relationship. But what we have want to know is more about the linear relationship. Relationship is calculated by the Pearson's correlation coefficient, okay, which is denoted as R. Okay, so Pearson's correlation will measure the linear relationship. It will not measure the curved relationship. Okay. Now, how to find out the direction of relationship? Okay, whether it is positive correlation or whether it is negative correlation. Okay, if both variables move in the same direction, then we call it as they are positively correlated with each other. That means if X is increasing, Y also increases. If X is decreasing, Y is also decreasing. Okay, that means they are positively correlated. Okay, they are correlated positively. Okay, for example, height and weight, gestational age and birth weight, education and income. If one increases, other increases. Okay, so positive behave like a partners. They will move together. So the variables which have the positive relationship will behave like a partner and they will move together. Okay, while negative correlationship, variables will move in the opposite direction. Like if one variable increases, the other decreases. So X increases, that will lead to the decrease in the Y. If X is decreasing, Y is increasing. So that kind of relationship is there. This is the negative correlation. For example, price and demand, exercise and BMI. Increase exercise, BMI will fall. Okay. Height growth and serum lipid levels. Okay. They have the inverse relationship. So negative variables or the negative correlation, they go opposite to each other. Okay. Now we will talk about the Pearson correlation coefficient R, which is seen in the linear correlationship. Okay. So numerical measure of direction of relationship and strength of relationship. Remember, this correlation coefficient R will tell us not only about the direction of relationship, it will also talk about the strength of the relationship between two continuous variables. Okay. So it is for the continuous variables. So two variables which are continuous in nature. What is the degree direction of relationship and what is the strength of relationship, and what is the value of this R coefficient of correlation, Pearson's correlation lies between -1 to +1. Okay, here don't confuse it with the standard error and R. Okay, so that is different. Here this R lies between -1 to +1. Okay, here there is a 0, but 0 also has got some meaning that we are going to see with respect to the Pearson's correlation. Okay, so R value varies between -1 to +1. If the R is towards -1, that means it is a negative correlation but a strong correlation. If R is +1, that means there is a positive correlation and strong correlation. Positively correlation and strong correlation. If it is a 0, that means there is no correlation. Okay, so +1 is a perfect positive correlation. 0, there is no linear correlation. There may be relation like U relation, J relation, etc., that we do not know. But at least there is no linear relationship, because Pearson's coefficient will talk only about linear correlationship. It will not comment about other types of relationship. Okay. If it is a -1, there is a perfect negative correlation. Okay. Now, how to interpret R? First, we will look at the sign, whether it is a positive or negative. If it is a positive, that means there is a positive relationship. If it is negative, that means there is a negative relationship. Then we will talk about the magnitude. Okay. Here we will now ignore the sign, whether it is positive or negative, but we will talk about the absolute value, whether it is towards 1 or -1. Okay, absolute value is what, 0.8, 0.7, like that. Okay, so what is the interpretation? If there is a 0 value of R, that means there is no linear correlation. 0.1 to 0.3 denotes weak correlation on either side. Okay, either positive or negative. 0.3 to 0.5, there is a moderate correlation. 0.5 to 0.7, that means there is a strong correlation on either side depending upon the sign. Okay, and more than 0.7, there is a very strong correlation. Okay, so this is the same thing is shown what we have discussed. Here it is a perfect positive correlation. Here it is a moderate positive correlation. Here it is a weak positive correlation. Okay, is it clear? Now here what you see is a negative correlation, but it is a perfect negative correlation. Here it is a moderate negative correlation. Here it is a weak negative correlation. Okay. And here you will find there is no correlation. Okay. So examples are gestational age and birth weight. Okay. Now, if the R value is given 0.96 plus 0.96, what do you mean? What do you get information from this? There is a positive correlation and it is a strong positive correlation. Okay. Because it is 0.96 closer to the 1. Okay. So very strong positive correlation. As gestational age increases, birth weight tends to increase substantially. Okay. So there are certain important limitations of Pearson's R. Okay. So it only measures linear relationship. As I have already mentioned, the R is related only to the linear relationship. If R is 0, it does not necessarily mean no relationship. It means that there is no linear relationship. Okay. So there may be other possibility, that is U-shaped relationship. Pearson's R may be near 0, but there may be strong association in other types of association, non-linear. Okay. So this R requires continuous variable. So you need to have two variables which are continuous in nature. Then only we can use the R. Okay. So use Pearson's correlation when variables are continuous and numerical in nature. Example, height, weight, blood pressure, birth weight, etc. And second, it is sensitive to outliers. Okay. So this R is very sensitive to the outliers. So one extreme observation can dramatically change the R. Suppose you look at this figure and you try to draw some line. So okay, now if you look at this particular samples, you may think that there may be some moderate or poor type of negative correlation if you draw the line like this. Okay, maximum observation will be around this line and there may be some negative, but if you include this R, this sample, and if you draw this sample, the negative has become positive. Okay, on either side it has gone. So it is very sensitive to the outliers. Okay, so always inspect the scatter plot before calculating the correlation. And next, another important point you should remember when we talk about correlation, correlation does not mean causation. Okay, correlation means just two variable go hand in hand, either positively or negatively. It does not mean there is a cause and effect relationship, one is causing the other. Okay, so this is the most important thing you should keep in mind, that the correlation does not mean causation. Okay, suppose there is a increased ice cream sale in the community and there are deaths due to the drowning. Is there any relationship? This is also increasing, this is also increasing, but is there any correlation between the two? There is no biological plausibility at all that this will be associated with this. So there is a correlation you are getting if you calculate, if you find out in this particular way, but it does not mean that ice cream causes drowning. Okay, so uh, because some other summer temperature is there, in summer people will go for the swimming, in summer people will increase eat the ice cream. That is why this is increasing, this is increasing. Okay, so it doesn't mean that the ice cream causes drowning. Okay, so this is what is the meaning of this. Correlation is not same as causation. Okay, so Spearman's rank correlation, there is something which is called as Spearman rank correlation. What we saw was a Pearson's correlation. Now what we are talking about is a Spearman rank correlation. Okay, these are two different things. One, what we have seen was a Pearson's R correlation, Pearson's correlation of coefficient. Here now, second, what we are talking about, the Spearman rank correlation. Now, when Spearman rank correlation is used, when you cannot use the Pearson's assumption, like Pearson will be used when you have got a two continuous variables. Okay, so suppose you are dealing with ordinal data, or your data is a ranked data, your data is non-normally distributed or non-linear relationship. In that particular case, you will use Spearman rank correlation. Okay, so that is what is the difference between Pearson and Spearman. Okay, so Remember, ordinal data, ranking of the data, non-normal distribution, and non-linear monotonic relationship. Okay. So in that case, we have to use Spearman's relationship. Okay. Example like a satisfaction score or pain scales, preference rankings, etc. Okay. Spearman scores become ranks. Okay. So here, when you are dealing with the scores or you are dealing with the ranking, you will use the Spearman. Okay. Now there is a difference between the Pearson Spearman. So Pearson is used when we are dealing with continuous data. When you have got a normal distribution, it actually uses the values. Okay. It does not use the rank, and it measures the linear correlation. While Spearman uses the ordinal or the rank data, then distribution, any type of distribution is okay. Actual values are not used. What it uses is the rank, and this is the rank correlation. Okay, Spearman uses rank correlation. Okay, so that finishes the concept of correlation. Now another concept is a regression. Okay, so correlation and the regression. Okay, now what we have seen, correlation, there are two variables which are either positively related or negatively related. Okay, so if we know one variable, we should be able to calculate the value of the other variable also, because we can find out some equation by which they are correlated with each other. Okay, so first what we should ask, are variables related? Okay, then in regression, can one variable predict another? So that is what is the importance of regression. If we know that they are related, can we find out one variable from the other variable? Example, okay, for the correlation, gestational age and birth weight. Okay, they are related to each other. Then in regression, can we predict the birth weight from the gestational age? Okay, that there comes the role of regression. Okay, so regression terminology, we have two variables. We have independent variable and we have got a dependent variable. Okay, so we have got the gestational age and the birth weight. Birth weight is going to be the dependent variable, gestational age is going to be the independent variable. Okay, independent variable also called as predictor variable or causative variable, that is X. Okay, here it is a gestational age, while dependent variable is the outcome variable, that is Y, that is the birth weight in this case. Okay, so we should get some equation, that is y. We want to know the value of y equal to a plus b into x. Okay, y equal to a plus b into x. That if we can find out, that is going to be the simple linear regression. Okay, this is the simple linear regression. Okay, so here what is y, what is a, what is b, and what is x? X, we have mentioned that it is the independent variable. Y is the outcome variable. Okay, so Y is the outcome or dependent variable what we want to predict. X is the predictor or independent variable which is used for prediction. Then A is the intercept. Okay, so A is the intercept of the line. Okay, that is the starting point, and B is the slope. Okay, slope, this line has got certain slope. Okay, so change in the Y for every 1 unit change in the X. Okay, so how does this y changes? This is the y-axis, this is the x-axis. How the variable will change? There will change in the y when there is a per unit change in the x. That is the slope. Okay, that is called as b. B denotes the slope. So you should know this equation, y equal to a plus b into x, and what everything denotes here. They can ask you that in this equation of simple linear correlation, b denotes slope, outcome variable, predictor variable. Okay, they will give you a number of options, so you should know what exactly each thing denotes in this particular equation. Okay, now there is a slope which is denoted as b. That is the most important parameter. What does that denote? That slope, that for change in the y for every 1 unit increase in the x. So if the x is changing, how much change is happening in the y? Because y is the outcome variable, x is the independent variable. For every 1 unit change in the x, how much is the variation which is happening? That is calculated by the slope b. Okay, so delta y upon delta x. So per unit change in y when there is a change in the per unit change in the x. Okay, so for example, B is 185 grams. Okay, 185. So for every extra week of gestation, birth weight increases by approximately 185 grams. Okay, so this is what is the interpretation if we take the example of the gestational age and the birth weight. Okay, now what does the slope tells? Okay, about us, that B. What does the slope tells? How much Y changes when X increases by 1 unit. Okay, now we talk about the intercept A. Okay, that is the value of Y when X is 0. So value of Y when X has become 0. Okay, when X value has become 0, what is the value of Y? That is the A, that is the intercept A. Practically speaking, there is no practical much meaning, but it is mainly used for the construction of the regression equation. Okay, so this is the regression line. Okay, this is the regression line. This is the intercept, and here is the slope. Okay, slope of the line. Okay, now here, once we know about this regression, we should also know, because we have got certain equation. Okay, Y equal to A plus B into X. That is what the equation we have called. So what we are going to get? We are going to get the outcome variable from the independent variable by using this intercept and the slope. Okay, but will always be the calculated and the practical will be same. Okay, so while you calculate by this mathematical calculation, but in practice, does it 100% same, or is there little difference? So there is little difference, that is called as residual error. Okay, so these observations will follow the relationship, but it will not always be 100%. There will be some error. Okay, that is called as residual error. That is the difference between the observed value and the predicted value. Okay, so you are going to predict the value by using that equation, but when actually the birth weight is measured, there is going to be little difference, and that difference is called as residual error. So formula for the residual error is observed value minus predicted value. Okay, so interpretation: if smaller is the residual error, that means your prediction is good. Okay, if your residual error is small, that means your prediction is good. If your residual error is large, that means your prediction is poor. Okay, so residual 0, that is the perfect prediction. If your residual, there is no residual error, that means you are perfectly predicting the value of Y. Okay, now positive residual, what does positive residual means? Positive residual means observation lie above the regression line. Okay, negative residual means observation lies below the regression line. Okay, then regression line is fitted such that the sum of squared residual is minimized. Okay, that is called as least squares method. Okay, so from examination point of view, you should remember certain things. Scatter plot is the first step in assessing the relationship. Positive correlation, variables move together. Negative correlation, variables move opposite. Pearson's R correlation is for continuous variable. Range of R varies between -1 to +1. R equal to +1 is the perfect positive correlation. R equal to 0, that means there is no linear correlation. R equal to -1, that is the perfect negative correlation. Then you have Spearman correlation for the rank or the ordinal data. Okay, then you have got a correlation which measures the association but not the causation. Okay, then regression will predict the outcome. Slope is the change in Y per unit change in X. Residual is the observed error minus predictor error, and correlation is not same as causation. Okay, so here the topic of correlation and regression is over. We have explained the concepts and seen with various figures also. Okay, we have certain SBS. Doctor, can you please go through this SBS?
Yes, sir. Question number 1. A scattered plot is frequently used for A. Test significance, B. Calculate mean, C. Assess the relationship between the two quantitative variables, D. Calculate the confidence interval, E. Compare the proportions. Sir, option is C of relationship between the two quantitative.
Yeah, two quantitative continuous variable actually. Next.
The correlation in coefficient range to +100, C -1 to +1, D 0 to infinity, E -infinity to +infinity. So option C, -1 to 0, +1.
Yes, yes. Okay. Next.
A coefficient, a relation coefficient of plus 0.90 indicate a weak negative correlation, no correlation, strong positive correlation, strong negative correlation, perfect correlation. Sir, C, strong positive correlation.
Correct, correct. Next.
A correlation coefficient of -0.85 indicate a strong negative correlationship, a strong negative relationship, weak negative relationship, strong positive relationship, no relationship, perfect positive relationship. Sir, it is a
What is the answer?
strong negative
Yes,
relationship.
it is a strong negative correlation. Next.
Which statement is true? Correlation proves the causation. Correlation implies treatment effect. Correlation does not imply causation. Correlation equals regression. Correlation measures the risk. Sir, option C. Correlation does not imply causation.
Correct, correct. Next.
Pearson correlation is most important for A, nominal data, B, rank data, C, continuously normally distributed variable, D, binary variables, and E, categorical variable. So C, continuous normally distributed variable.
Yes, you should remember that if we use Pearson's correlation, there are certain assumptions. Data should be normally distributed and data should be continuous. We should be dealing with the continuous variables. Okay. Next.
Which statistic should be used for rank data? A, Pearson correlation, B, chi-square, C, ANOVA, D, Spearman correlation, and E, t-test. So answer is D, Spearman correlation.
Yes, here it is a Spearman correlation because we are dealing with the ranks. Next.
Researcher finds R is equal to 0, which interpret the best. No relationship exists, no linear relationship exists, strong negative relationship exists, strong positive relationship exists, causation absent. Sir, B, no linear relationship exists.
Correct, correct. So don't go for no linear relationship. There may be other non-linear, maybe there. We don't know. Accurate will be no linear relationship exists. Next.
Correlation is A, no effect, B, may substantially changes R, D, C, changes in sample size, D, it changes significant level, E, it converts Pearson to Spearman. So answer D, it changes significance level.
Oh, it may substantially change the R. No? It will change the R value. Next.
A regression is mainly used for A, measure prevalence, B, compare proportions, C, predict one variable from other, D, calculate a p-value, E, assess randomization. So answer C, predict one variable from other.
Correct, correct. Next.
In regression, it is predicted variable, B, independent variable, C, outcome variable, D, exposure variable, and E is confounder. Sir, birth weight will be dependent variable.
That means
Dependent
outcome. That means
outcome
the
variable.
outcome. Okay. See.
Okay.
Next.
In regression equation, the slope represents the value of x when value of y when x is 0, strength of correlation, changes in y for 1 unit, increase in x, p-value, and E is residual error. So answer C, change in y for unit, increase in x.
Yeah. So that is the role of the importance of slope. That will not change y or 1 in x. Okay. So that finishes the today's session correlation.